Here's problem 3513. A person in a boat sees a fish in the water. Index of refraction 1.33 for the water. The light ray is making an angle of 40 degrees relative to the water's surface. What is the true angle in degrees relative to the water's surface of the same rays when beneath the surface? Alright, let's imagine what's going on here. We have a water surface, and we'll set up a normal to the surface, and we have a light ray that is coming out at a 40-degree angle with respect to the water, and that's going to be seen by a person in a boat. So they're going to be watching this, and the light ray is actually originating from a fish that's in the water. So the light is coming from the fish, refracting as it's going from water to air. So the first index is water, 1.33. The second index is air, 1.0. Snell's law should apply to this situation. We should have that index 1 sine theta 1 should equal index 2 sine theta 2. Now in this case, theta 2 is this angle right here, 50 degrees. Theta 1 is this angle of incidence with the normal, and that's what we wish to find out. So it will be true that theta 1 will be the inverse sine of index 2 divided by index 1 sine theta 2. That's going to be the inverse sine of 1 divided by 1.33 sine 50 degrees. And what is that? 50 sine divided by 1.33 inverse sine 35.2 degrees. That's our theta 1, 35.2 degrees. But the question was, what is the true angle relative to the water surface of the same ray when beneath the surface? So we just found theta 1, but we want to find this angle here, let's call it alpha, which is the complementary angle. So alpha should be equal to 90 minus theta 1, which will be 90 minus 35.2, or 54.8 degrees will be the angle that ray made with respect to the water surface underneath the water, 54.8 degrees.